All right, let's talk through this. In statement number 1, I have that JK is congruent to LM, and then they tell me that LM is also congruent to PQ. And so that lets me jump to this statement back here that, well, then obviously JK and PQ would have to be congruent because both of them are congruent to LM. What reason do we use to be able to make this statement if we know this part? If it was equal signs, I could use substitution, but it's congruence signs. I can't use substitution when it's congruence. I didn't hear what you said. Transitive. My transitive property. Again, if I had equal signs here instead of congruence, I could use substitution here. When it's congruence, we can't ever use substitution. Kind of stinks because I like substitution. Transitive property specifically says if I know one object is congruent to a second object, and then I know that same second object is congruent to a third object, then that means the first one and the third one have to be congruent to each other. Transitive property, I'm always talking about 3 things and 3 things only. The first one is congruent to the middle one is congruent to the third one, so the first one and the third one have to be the same size. All right, number 2, I have segment AB is congruent to segment CD. So what would let me turn that around and say, well, then that means that CD is congruent to AB? Symmetric property. For number 3, we start off by knowing that Y is between X and Z on segment XZ. Then why would I be able to say that the length of XY plus the length of YZ is equal to the length of XZ? Yes. Segment addition postulate, yes. And then our last one, we have that segment DE is congruent to itself. Reflexive. I had a really good question first period. A student asked me, what's the difference between the symmetric property and the reflexive property? Here's the way I remember the difference. Reflexive property is kind of like you're looking in a mirror. You are the same shape and size as you. So you're looking in the mirror, you're looking at yourself. You are congruent to yourself because you are the same shape and size. It's the same object in both places, just one is the reflection of the other. Symmetric property is more like if you had an identical twin. If you look at your identical twin and you guys are dressed in the same outfit, you're exactly the same shape and the same size as your identical twin, but you don't have the same name as them. They're not the same person as you, but they have all the same characteristics, same shape, same size, same outfit. So 2 different objects that are the same as each other. You could say, I am the same as my sister in my looks, in size and shape. Your sister could then say, well, I am the same as you. So with symmetric property, we're talking about 2 different objects, and I can flip them around either way. Reflexive property, we're talking about just one object, and we're saying it's the same as itself. All right. I want you guys to grab the notes that we were working on yesterday, the 3-5 notes. We're going to finish those up first, and then we're going to dig into those 3-6 notes that you should have picked up on your way in. Also, today is Friday, which means you're going to do what at the end of class? Turn in your warm-up paper. Yes. You don't have 3-5. Not a problem. Here's the notes and the homework. The homework's due on Monday. You're welcome. All right. This guy right here looks kind of weird. Yes. Oh, you need those as well. This is called a flowchart proof. What we've been working on up until now is called a two-column proof. You need one as well. A two-column proof, I have a column for my statements. I have a column for my reasons. And the statements and reasons that go together are right across from each other. They're like on the same line, but just in two separate columns. With a flowchart proof, this lets me see which pieces of evidence I'm using to make the next statement. So it's got these little lines connecting these pieces. I have to have all three of these pieces of information in order to make this statement here. In a flowchart proof, my statement goes on top and my reason goes right beneath it. So in each little box, I have a statement and then why I'm allowed to say it. If nothing comes before it, then it's either coming from my given information or it's coming from the figure that they gave me to look at. So my reason for this one right here, why is Li equal to An? Because it's given. The next box over, again, this doesn't rely on my given information, and it doesn't rely on anything else, so I'm going to look at the picture to try to figure out why I'm allowed to say this. It has LA, this segment right here, together with AI, this segment right here, and when I put those lengths together, it gives me the length of the whole segment. What are we using to say if I take the length of this little segment and I add it to the length of this little segment, it gives me the length of the whole thing? Segment addition postulate. All right. What about the next one over? Over here I have AI, this segment right here, together with IN, this one right here. And when I put those together, it gives me the length of AN. Why am I allowed to say that? Segment addition postulate again. Do you have these notes, dear? No. These were passed out yesterday. Let me see if I can get you an extra copy. It's this one right here. We're on the second page. All right, I'm going to use all three pieces of information here to make my next statement. LA plus AI is the start of my next statement. Well, I see that right here. And that's the same as what? LA plus AI is equal to, it's the same as what? Li. Well, there's an Li right here. So if I replace this Li with LA plus AI, that gets me right here. What would allow me to make that replacement since these things are equal? Substitution. Okay, so that gives me that piece. What about this AI plus IN? I see AI plus IN right here. It says it's the same size as AN. Over here I have AN. I can take this AN out and I can replace it with this because they're of equal value. What would let me do that? Substitution. So we use substitution in two spots for that. That's my substitution property there. Do you guys notice anything about that equation? Anything that's the same on both sides? Yep. AI and AI is the same thing on both sides. If I've got the same thing on both sides, can I take it away from both spots? So that would get me to right here. If I take it away from both spots, why am I allowed to take the same thing away from both sides? Subtraction property of equality. Something I want to warn you guys about, because I have people constantly asking me, can I abbreviate stuff? And yes, you can, but be careful with your abbreviations. Here I have substitution and then subtraction. You can't abbreviate substitution, SUB, and also abbreviate subtraction, SUB, because I won't know which one you're talking about. You got to give me more of the words that I know whether you're talking about substitution or subtraction. You can abbreviate the other words in there, but give me enough of substitution or subtraction that I don't mistake one for the other. So don't just use SUB for those. All right, let's flip over to the next page, and we're going to fill in this flowchart proof. This one we have to give the statements and the reasons for. So in this top box right here, I'm going to put my given information. Segment RT is congruent to segment WY. Segment ST is congruent to segment WX. What would I put below in the reason part of the box? Given. Let's see if we can figure out what goes in this other box over here that does not rely on my given information. If I'm not looking at my given information for this, I probably need to be looking at the figure. I've got two different line segments here. Let's look at just the top one for a moment. How many points are on that line segment there? 3. So how many little segments are there? There's 2 little ones, and together I can put them, I can put them together to get the whole big line segment, right? What are the 2 little line segments that I would put together? RS and ST. How do we put things together in math? We add them. RS plus ST. When I put those lengths together, it gives me the length of what? RT. Can I make a similar statement about this line segment down here? All right, so tell me what that one would be. WX plus XY equals WY. What's my reason for that? Why am I allowed to say that? Segment addition postulate. All right, so those are the statements that I can make that don't depend on anything else. When I've got these arrows here, I've got 2 arrows pointing to the same box. That means I have to use this information together with this one over here in order to make this next statement. I don't know what goes here, so I have to wait to make this statement. If I come over here, these 2 boxes only rely on my given information. So what can I say if I know that RT is congruent to WY? Their measurements are equal. What about ST and WX? Same thing. Why am I allowed to say that? It told me they were congruent. Why am I allowed to take it one step further and say that means that they have to have equal measurements? What'd you say? Definition of congruent segments. All right, so before I decide which box I'm going to write these in, I see an RT right here, and an RT here, a WY here, and a WY here. I'm going to put that in this box because I think I'm going to have to use it with this because I have RT and WY. So RT, no, sorry, no dash over it. Segment RT, the length of that is congruent to the length of segment WY. That would be my definition of congruent segments. And over in the other box, I have the length of segment ST is congruent to the length of segment WX. And again, that would be my definition of congruent segments. Here I have RT. Well, here's RT, and it tells me that it is equal to RS plus ST. So can I swap those things out? Yep. So I would have RS plus ST equals, well, here I have WY, but up here it tells me that WY is equal to WX plus XY. So I can exchange that in this equation right here. I can replace my WY with WX plus XY. What did I just use to be able to make those replacements? Substitution. Got my substitution property happening here. Okay. Because of these two arrows, I know I'm going to use this that we just wrote together with information that's over here. If ST is equal to WX, then anywhere I see an ST, I can replace it with a WX. That's what it means to be equal. I can swap things out that are of equal value. Do you see an ST in that equation that we just wrote? So I can swap that out. I can have RS plus ST, or sorry, plus WX. I'm going to replace that with WX equals WX plus XY. I just swapped something out that has equal value. What am I using to be able to do that swap? Substitution property. Is there anything that you guys notice that's interesting about this equation? What'd you say? There's two WX's. There's one on the left and there's one on the right. If I have the same thing on both sides, what can I do with it? Subtract it. RS equals XY. I got rid of the WX on both sides using what? Subtraction property of equality. Well, if I know that RS is the same size as XY, then what do I know about those two segments? If I know they're the same size, then they have to be congruent. Segment RS is congruent to segment XY. What am I using to be able to say that? I knew back here that they were the same size. Why does that mean they're congruent? What are we using to be able to make that leap? Definition of congruent segments, absolutely correct. Very nice work. All right. We're going to spend the next couple minutes doing some review problems with angles. We did these in Module 2. We're going to review these ideas now in number 6 and number 7. Let's look at number 6 first. Tells me that angle 1 is 4 less than the measure of angle 2. What symbol do I put in the place of is? Is means what when I'm reading a sentence like this? Equal. So the measurement of angle 1 is equal to. What does 4 less mean to do? Subtract 4. So this is minus 4. I'm going to subtract 4 from something. Here it says triple the measure of angle 2. What does triple mean to do? Multiply by 3. What are we multiplying by 3? The measure of angle 2. So I have 3 times the measure of angle 2. Equals 4. What else do I know about angles 1 and 2? They're supplementary. What does that mean? The sum equals to 180. So the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Something I want to pause and state real quick just because I saw it happen often enough on the Module 2 test. We did a really good job of remembering that supplementary and complementary meant things about 90 and 180, but sometimes we got it confused as to which one meant which. If you're looking at a number line, which one comes first, 90 or 180? Which one would come first on a number line? 90, because it's smaller, right? So I'm going to see 90 first before I see 180 on a number line. When you're looking at the alphabet, which one comes first? C for complementary or S for supplementary? C. 90 comes first on the number line. Complementary comes first in the alphabet. 90 and complementary go together. 180 comes later on the number line. S for supplementary comes later on in the alphabet. 180 and supplementary go together. All right. I know that the measure of angle 1 is equal to this right here. If things are equal, I can swap them out using what? Substitution. Do you see the measure of angle 1 anywhere else? Right here. So in the place of this, I'm going to put 3 times the measure of angle 2 minus 4. And then I have to bring down the rest of this equation, plus the measure of angle 2 equals 180. The measure of angle 2 is the name of my angle. That's how big that angle is. Do we know how big angle 2 is? Then it's just this unknown thing. I'm saying far over on the left that I have 3 of this unknown thing. And then later on in the equation, I have another one showing up. If I have 3 of this unknown thing over here, and over here I have another 1 of the same thing, how many do I have? I have 4 measure of angle 2's. So I'm going to combine these 2 like terms together. I have 4 times the measure of angle 2 minus 4 equals 180. What would I need to do next to this if I'm solving it for the measure of angle 2? Add 4 to each side. So I would have 4 times the measure of angle 2 equals 184. And then I would do what? Divide both sides by 4. What is 184 divided by 4? What is 184 divided by 4? 46. So the measure of angle 2 is 46 degrees. Have I fully answered the question? They also wanted me to find what? Measure of angle 1. How do I figure out the measure of angle 1? I can substitute it in. Measure of angle 1 equals 3 times the measure of angle 2 minus 4. So now I know that the measure of angle 2 is 46 degrees. What's 3 times 46? 138 minus 4. What's 138 minus 4? 134 degrees. How can I check to make sure that that's most likely right? Add them together. It should add up to how much? 180. 134 plus 46. 4 times 6 is 10. 1 plus 3 plus 4. That's 8. 180 degrees. So I'm pretty sure I did this right. Let's go do number 7. We're going to mark this picture up first. We're going to talk about all the relationships that we see here. We have the measure of angle LKM is 2x plus 10 degrees. Well, here's LKM. 2x plus 10 degrees. The measure of angle MKN is 3x minus 15 degrees. MKN, 3x minus 15 degrees. I want to pause right there for just a second. What do I know based on the picture about those two angles when I put them together? This angle and this angle. When I put those together, they're 90. They're complementary. How do I know? PKL has a 90-degree angle. So over here, LKN would have to have a 90-degree angle. So what do I have to do with the 2x plus 10 and the 3x minus 15 then? Are they equal to each other? Are they the same size? We're going to add them together. And when I add them together, they should add up to how much? 90. The measurement of angle LKM plus the measurement of angle MKN is equal to 90 degrees. So I would have 2x plus 10 plus 3x minus 15 equals 90. Are there any like terms that I should be combining together? Which ones? 2x and 3x, 10 and negative 15. These are all on the same side, so I'm just grouping them together and figuring out how many I've got. If I have 2 x's and 3 x's, I have how many x's total? 5 x's. 5x. What about if I got $10 and then I owe somebody 15? Negative 5 equals 90. What do I do next? Add 5 to both sides. So 5x equals 95. What do I do after that? Divide both sides by 5. What is 95 divided by 5? 19. X equals 19. That's one of the things they asked me to find. What else do they want me to find? They want me to find y. We didn't even add that to the picture yet. Measurement of angle NKO is 7y minus 14. Well, here's NKO, 7y minus 14 degrees. How am I going to figure that out? I'm going to add which things together and get it to add up to 180. You're absolutely right. MKN and NKO. So the measurement of angle MKN together with the measurement of angle NKO equals 180 degrees. They share this side right here, so they are adjacent. And together they make this straight line right here, which means they are a linear pair. How big was MKN again? That's 3x minus 15, right? MKN, this guy right here. And then I'm going to add that to NKO. NKO was 7y minus 14 equals 180. Do I know how big x is? We just found out that x is how big? So 3 times 19 minus 15 plus 7y minus 14 equals 180. What is 3 times 19? 57. So 57 minus 15 plus 7y minus 14 equals 180. What's 57 minus 15? 42 plus 7y minus 14 equals 180. Well, I've got 42 minus 14. What's 42 minus 14? So 7y plus 28 equals 180. Subtract 28 from both sides. I get 7y equals what? 152. When I divide both sides by 7, does it come out pretty? What do we get when we divide both sides by 2? 21.71. It's not exactly equal to that. We had to round, so I'm going to use my approximately symbol here. All right, we found x, we found y. What else are we supposed to find? P, K, O. I need this angle right here. How am I going to find that out? MKN is the same size, right? Those are vertical angles. You could also substitute in here and say those two have to add up to 180. So I have the measurement of angle PKO is equal to the measurement of angle MKN. That was 3x minus 15. We know that x is 19. So 3 times 19 minus 15. What is 3 times 19? No, that's not. 57. And 57 minus 15 would give me what? 42. So the measurement of angle PKO is 42 degrees. All right, last couple minutes, we're going to switch over and just barely start those 3-6 notes, what you picked up on your way in the door. We're going to look at this first proof. Angle 1 and angle 2 are supplementary. What's my reason for that? Given. So they're telling me that this angle here is supplementary to this angle down here. But I also notice that angle 1 is right next to angle 2. They share a side. They share this side right here, and together they make this straight line. So what special angle pair would we call this? A linear pair. Angle 1 and angle 2 are a linear pair. That is the definition of a linear pair. What do we know about the measurements of the angles in a linear pair? They're equal to 180. Angle 1 and angle 2 are supplementary. That would be my linear pair theorem. Both of these guys came off that golden sheet. Supplementary angles add up to how much? 180. So angle 1 and angle 3, so I wrote something wrong here. That should have been 3 up here. Angle 1 and angle 3 added together equals 180. I'm using this right here. Measurement of angle 1 plus the measurement of angle 2 also adds up to 180. That's coming from right here. That would be my definition of supplementary angles. If I have two different things that are equal to 180, can I say that they are equal to each other? X is equal to 180, y is equal to 180, so is x equal to y? Yes. Measurement of angle 1 plus the measurement of angle 3 would be equal to measurement of angle 1 plus the measurement of angle 2. That's using substitution. What do you notice about both sides of that equal sign? They both have angle 1. Guys, 3-5 homework is due on Monday. We have the measurement of angle 3 is equal to the measurement of angle 2 using the subtraction property of equality. Don't forget to turn in your warm-up. Sorry, Mia.